Hello. So let's solve today's problem. Implement two stacks in an array. And in this problem, we have to implement stacks in one array. So what we have to do is first visualize how we can place two stacks such that it becomes an array. So stack looks like this in which we insert the element at the bottom, right? And then yeah, and then here. So it is a LIFO data structure, last in, first out. All right. So that was it for the stack. And now what we have to do is to implement this stack to two stacks in an array. So what we can do is we can place one stack like this. So like this in a horizontal manner. You can visualize it in the horizontal manner and the second stack like this, right? So what we are going to do is for the first stack, suppose let me mark it as 1 and let me mark it as 2. So suppose for the first stack, so the size of the stack is same for both the stacks, right? So let us mark here as the size of first stack and let's join it. So initially for stack 1, our top pointer, since we are given two top pointers, top 1 and top 2, so the first top pointer will be placed at -1. So if you don't know, the while inserting the very first element, our top pointer is always in a slash to -1. This indicates that there is no element in our stack. So initially, for the first stack, we have our top pointer at -1, right? So we will start implementing as usual. Like we will increment our first the top pointer and then push the element in our stack. Again, we will increment the top pointer and push the element. And wha- and once it reaches the size, for example, once our top pointer reaches here, what we're gonna do is we're gonna place the second our top two pointer now. Here comes the role of second stack's top pointer. So it will be placed at the size because we have joined the two stacks such that one is like this and the other one is like this. So the top one, the first top pointer should be here, and the second top pointer, second stack top pointer should start from here, right? From where the means if the first top one has ended up pushing the elements till size, right? So it has reached till size. So our top two should start from size plus one, right? So this size plus one is nothing but from here onwards, not from here. So we will initialize our second top pointer from top to equal to size. I hope you get the idea why we are initializing the second top from the size, because we are inserting we have joined the two stacks such that one is like as usual and second is in the reverse manner. All right. And while deleting the elements, we will delete the elements from the first stack as usual, means first we take out the element, then we decrement the top pointer. And the base condition should be for this top one until the top one reaches -1, we stop. And for this uh, top pointer, the base condition should be one it till it reaches the size because suppose it pushed the element till somewhere like here. So now while eliminating it, we will move our top pointer here, not the right side. Okay. So once it reaches till size, we will stop. Let's implement this code. Here, plus plus top one equals x. So this will do for the first stack. Now let's do for the second one. Here are all. Now we have to decrement. All right. Since we are standing on the size, so we have to move in the negative in the opposite direction. Since you can see the top two is initialized at this size, so we decrement the top two. Okay. So first we decrement the top two, then we insert the element. Now, while decrementing it means while deleting the element. So return top one equals -1. If it has reached -1, means there are no element in the stack, so we return -1. Otherwise, we return ARR of top one -1. Means first we take out the element, then we decrement the top pointer. And in case of top two equals size. If it has reached the size, then we return -1. Otherwise, we take out the element and increment our top two pointer. So let's compile and run. Seems like it's working fine. Okay, thank you.